Thank you. Okay. Good. Awesome. All right. Yeah, thank you all so much. For anybody who doesn't know me, my name is Richardson. I also go by Arson. And today I'm going to be talking to you about my new bug bounty hunting framework, the Ars0n Framework version 2. So I'll talk a little bit more about myself first. I am a very proud United States Army veteran. I have some, let's go. I have some degrees and certifications you're welcome to read up there. I'm not going to read them out to you. I specialize in product security engineering for SaaS companies, software as a service companies. And product security, that means web application, cloud infrastructure, and the AI systems as of the past couple of years that are integrated with them. So take a lot of pride in having a depth of knowledge across all three of those realms there. As far as bug bounty hunting goes, I submitted my first bug bounty report back in 2019, so I've got about 6 years of experience as a researcher. Primarily, that is as a side hustle, as part-time and everything. I also led the application security team at Flowcast to build and maintain a public bug bounty program on HackerOne. So I've been very lucky to have both sides of the coin there, where I've been a researcher for 6 years, as well as being able to build, maintain a program, and get all those reports coming in. And again, if anybody doesn't know me, I have a YouTube channel where I share out free educational material. I have a GitHub with free tools. My full methodology is on there. So I have some QR codes down there at the bottom. If anybody wants to grab those, you can go and check out anything that I have for free. So today I'm going to be talking about my new framework. Like I said, so the goal of the framework is if somebody wants to start bug bounty hunting, on day one they can download my framework. It is going to automate all of the processes that create friction at the beginning when people are starting bug bounty hunting. So it's going to automatically download over 20 tools that are used to conduct recon. And the user interface is designed so that as you walk through it, there's really no other way to use the tool other than to learn a correct methodology. So you're going to walk through and run everything. It will automatically pull the data into the next step. And we're going to see me walking through all of that right there. But ideally, if somebody wants to start... Cool. Sorry. Ideally, if somebody wants to start bug bounty hunting, they can download my tool by, let's say, about 3 p.m. in the afternoon, and by 6 p.m. that night, they've already got a full set of recon data, and they can go out and start learning and testing on a real bug bounty program. That's really the scenario that I'm trying to create there. So some of you may know that this is version 2 of the tool, like I mentioned. So if you've used version 1, there's going to be a lot of improvements from the first one. But really, the fundamental difference is that when I built version 1, it was a collection of scripts that I had built over time that I eventually put into an API and then had a front end on it, grew organically based on needs that I had. And then after doing YouTube videos, people just asked me to share it out, and I did. Version 2 has been very specifically architected to be shared as an open source tool. So there's been a bunch of technical changes. Probably the main one is I've gotten rid of MongoDB. On the back end, if anybody had any issues trying to download and install it, specific processors and everything didn't work that well. So I've gone and replaced that. The back end in Python has been replaced with Go. Yeah, so a lot of additional things, many different, bunch of different functionality and everything, but fundamentally, the tool has been architected so that it can be distributed successfully as an open source tool, which was really a lot of the problems that people had with the first version there. So when you first download the tool, you're going to have two different options. You can either go in and you can start from scratch, and that's what the majority of this presentation is going to be, by creating a new scope target, and then you'll go through and run your recon and build up everything there. However, if you don't want to wait and go through the recon process yourself, the other thing that you can do is you can import scan data from another instance of the framework. So if you know somebody else that has already completed their recon and their scanning, you can just import their .arson file that they've easily exported from it. Now that's fantastic if other people that are working, you're collaborating with other people. But if you're just starting out and you don't know anybody, then you can use my data. So I've created a repo that has my data on several different public programs, and the ones that I test, you can see there, GitHub, Grammarly, GitLab, things like that. I have gone through, and I'm going to continue to maintain this. So I've gone through and collected all of the recon data against these main targets. I'm going to be creating videos and everything for that as well. So if you want, you can install the tool, you can go on to this GitHub, you can get the URL that will point to the raw Arson file. When you put it back in the framework, it will pull all that data in, and right away you can start testing with the exact same recon data that I'm using when I'm conducting my testing. And if I'm doing a live stream to where you see me doing live testing on Grammarly or anything like that, and you want to participate, you just go on there, you grab the data that I'm using, put the URL in 2 minutes, you have this framework. You're going to have a full set of recon data, the exact data that I'm using, that you can go and conduct your own testing. Oh, yeah. Thank you. Thank you. So if you don't want to import that data and you want to go ahead and build your own data, you're going to do one of these three workflows here. So first of all, you look down at the bottom of the URL workflow, there's some under construction things there. That has not been built out yet, and the reason for that is ultimately when you're conducting testing directly on a target URL on a series of URLs, that's really what Burp Suite is for. So I don't want to build a competitor to Burp Suite. I'm not going to build anything better than that. I have a pivot point to go there. So eventually the URL workflow is going to be an educational workflow. It's going to build out dynamic lesson plans against real-world targets. So it'll go through and identify, hey, this target may be a good for client-side injections. Here's why, and then it'll show you those attack vectors and go through and help you do that. So that's something I'm going to build out in the future. The company and the wildcard workflow, however, have already been built out, and they essentially automate the entire recon process from start to finish. So the company workflow, you're going to start with the company name. You're going to put it in there, and by the end of the workflow, you're going to have the full attack surface, and we'll talk through everything that means. But any external-facing asset that you can go out and conduct testing on, you're going to be able to identify that, and you can conduct nuclei scanning on that as well. It's got all that built in. You can do your own custom templates and everything. And then the wildcard workflow is, and we'll talk about this a bit more, but it's probably the most common workflow that most of you are familiar with. So we start with a root domain, and we want to find all subdomains that exist that are potential targets, which one of those are live URLs that we can test in. Right? And the company workflow does feed into the wildcard URL, and it comes back as well there. So we'll go ahead and look at the company workflow first. And again, like I said, and this is part one of the company workflow. So we're going to start with the company name, and we're going to talk about finding any on-prem assets that we can potentially target for testing. And then we're also going to find any root domains that we can pass over to that wildcard workflow to find additional subdomains there. Move this over here. I'm going to take a sip of water. Does anybody want to tell me what that picture is? I'm super curious to know. This may be dating myself. It's a demarcation point. I'm wondering if anybody else. All right. Yeah, again, it's dating myself a little bit. I saw a lot of these early in my career there. But okay, so the first thing we want to do in the company workflow is we want to identify on-prem assets. So if a company wants to host their own infrastructure, whether they're hosting web applications, VPNs, SFTP servers, whatever it is, if they want to host their own infrastructure, they're going to go to an internet service provider, an ISP, and they're going to tell them they want to purchase a range of IP addresses. And what the ISP is going to do is it's going to assign them what's called an autonomous system number, or an ASN. So that number correlates to a range of network, or multiple different network ranges that are based on the IPs that they now have that they can serve in their infrastructure externally to the internet. So that's the first thing that we want to find. Now the good thing is, when they go and register this, not only do they tell the ISP what range of IPs they want, they also fill out a string that essentially identifies the company name. So we have three things with ASNs. We have the company name, we have the ASN number, and then we have the network ranges that are associated with the ASN that we know are a range of IP addresses that could be hosting potential targets for bug bounty hunting. So we can search the company name in those strings and identify the ASNs and the additional things there. And that's how we can start to build out the attack surface from just having the company name. So the way my framework is going to do that is it's going to use two different tools, AMAS Intel and MetaBigger. It's all built in there, so you can just click one button and automatically scan it. It's going to take the company name and go out there and try to find it. If it does find any network ranges and ASNs that are associated with that, the next thing it's going to do is it wants to find out if any of those IP addresses and any port combinations are live so that we can conduct testing on it. So what it's going to do is open a raw socket, and it's going to send a TCP send packet out to every one of those IP address and port combinations to see if it sends back an ACK. We don't want to do a full TCP handshake because that's going to take too long, right? So we go out and send packets to each one. If it responds with an ACK, we know that we have a potential target, and then we start probing for what the protocol is and everything else and start to do that. My framework takes care of all of that. You just click a couple buttons. It will automatically pull that down, and at the end, you will have a list of protocol, IP address, and port combinations that are potential targets for bug bounty hunting that you can either go in and test, or you can pass it on to the additional modules within the framework there. So that's the first major component of part one of the company thing. The next thing we want to do with the company workflow, the next thing we want to do is we want to find root domains. So a root domain is the core domain where all other subdomains are going to branch off of, right? So we have several different ways to do that, and it's more of an art than a science, or maybe about 50-50. It's not as straightforward as some other process. You have to go in and figure out does the company actually own this, and do some probing and everything else. But we have a lot of different things to help do that. So the first thing we have is manual Google dorking. I want to put a pin in that because that's the next slide here, and I'll show you how I've built to hopefully solve, or what I've built to hopefully solve that problem. We're also going to use certificate transparency logs. So just like when a company goes and registers an ASN number, if they want to register from a certificate authority a certificate, they're going to fill out that information. They're going to include the domain that the certificate is registered for, and then their company name. These are all public information that we can search through the certificate transparency logs. My framework does that automatically. You click a button, takes the company name, goes out and pulls back any information for certificates that it has, and you can go through and trim out any ones that you think are not a correct match. We can also do a reverse whois lookup. So for anybody that's not familiar with a whois, that is the way of querying for the information that was registered when a domain was registered, the information that was collected when a domain was registered, right? So it's all the same type of thing. We've got this human text readable information in this whois lookup that is connected to the domain. So if we can search for the company name and it shows up in there, we can know with some degree of certainty that is going to be a valid target that we can test in. Now the problem with that is that a whois lookup, there's no way to easily do that backwards, right? You have to do what's called a reverse whois lookup, which means somebody has to have a service that's running all the time, going and performing this whois lookup, storing the results in a database so that you can search those results in a database in the whois and tie it back to the correct domains. So you have to use some external services to do that. There's no way to automate it. I tried to make it as automated as possible within the tool. You can see in one of those circles a little bit there, but ultimately it will automatically take you to the two most reliable services that I use, and you can go down there and copy it back into the framework and put it in there. So I tried to make it as automated as possible, and even when it's not possible to automate those. For root domains, we also have integrations with several common tools that people use and services that people use. So census and security trails, Intel companies. If you already have an API key, put that into the framework, it will automatically pull that data down and it will add that to your list of root domains. Shodan as well. So if you have a Shodan API key, it'll go. Now Shodan, it gets a little bit less reliable because they do a lot of more kind of open stuff, so you've got to make sure it's actually owned by the company. And then GitHub is the last one. If you have a GitHub pat, what it'll do is search using the API for the company name and any code patterns, and then look for domains that might be in that code. Right, so it gets less reliable as we go through it. You've got to understand, do a little bit of testing on it, but eventually you'll get that feeling and you can trim them out within the framework there. So ultimately, once we have that, we have a list of root domains. We're going to consolidate that into a single list. I'm going to say that about 15 more times during this presentation, so please buckle up for that. And then we can pass it off, and we're going to do another metadata scan. So a lot of times we're going to consolidate, and then we're going to run an additional scan so that we can identify, just gather additional information about whether or not these root domains are valid. Can we make an HTTP request to it? Does it have SSL certs? Does it have an outdated cert? All this information so that you as the user can make the best choice about whether or not you want to dig deeper into that. And if you look at the last line on here, so for any root domains that you do want to pass over, you can pass to the wildcard workflow, and that's where you can start to find all those subdomains that are included in there. Now, before I move to that, like I said, I want to talk about the manual Google dorking because this is accidentally one of my favorite pieces of the framework. So manual Google dorking is the way I find 90% of my root domains as I'm going through and testing all these different things. But it's a pain. You have a list of dorks that you're testing over here that you go in and search, and then you have to there's always a bunch of different tabs going on and everything. It's been a problem that's always frustrated me for a while. So I was able to build this utility within the framework. You just click on the manual button and this modal comes up. It has hundreds of different Google dorks that are already built in that are specifically designed to find root domains for bug bounty hunting. So you just go through and click that load button. It's going to load up directly in the frame where you're working, and that little frame there. You can scroll down. You can switch to the next pages. It's got enough. It basically grabs the front end of the DOM. It's not fully functional, but it grabs that and renders it in there so that you can use it. So you can scroll through, find any of the domains you want. I've got keyboard hotkeys in here as well, so you just hit tab, you type the domain in and hit enter, it will automatically add them. So the really cool thing about this, because again, I have a lot of success with the manual Google dorking, it's taking something that was a pain for me, but successful, and it's turning into something that's now fun and successful, which means I do it 2 or 3 times as much as I used to do it, and have 2 or 3 times the success. Like I said, I hope you enjoy that as much as I do. That ended up accidentally being one of my favorite features, and I wanted to highlight it in here. All right, so moving on to the wildcard workflow. And this is probably the most well-known bug bounty workflow that exists, right? We're starting with, whether it's a target in a bug bounty program or something you found otherwise, we're starting with a root domain. My example here is google.com. and we want to find all subdomains that exist. Any domain that's been registered that's a subdomain of that, and then which one of those subdomains point to a live web server that is a valid target for testing there. Now, I'm not going to dig into each step of this too much, but essentially I have fully automated Jason Haddock's bug bounty recon methodology version 4. I'm not going to take credit for that, right? He came up with this great methodology, and I just put it together so the framework does it as easy and as automated as possible. So we start with web scraping, right? We go out to all these different public areas where we can grab the information about the subdomains. That's sublister, AMAS, get all URLs, CTL, certificate transparency logs, and subfinder. Brings those back, consolidates them into a single list from all 5 tools of subdomains, and then passes them to HTTPX, which is going to find out which one of them are live web servers. So we've got to have those live web servers, because in the next round, we're going to do brute forcing. And the first thing we're going to do is we're going to take all those live web servers, and we're going to pass them to a tool called CEWL. Cool. And what Cool is going to do is it's going to crawl each one of those live web servers, and it's going to build a dynamic word list based on what words it sees repeated over and over again in the DOM or in the JavaScript, etc. So the hope is you can find unique naming conventions that are specific to the company that you are targeting. So it's going to run through, it's going to build that dynamic word list. It's also got a huge static word list that I use every time I run this brute forcing. It's, 10,000 plus subdomains there. It'll use shuffle DNS to go through, and now we have a new list of additional subdomains. Add that to our consolidated list, run it through HTTPX again. We got a longer list of live web servers, and then we pass that so we can crawl each one of those, and we find any additional subdomains that are located in the DOM, in the JavaScript files, anything that might be associated in there. So after that last round, it's going to take a little while. We pass it back for one more time, consolidate to our final list, run HTTPX, and we now have a list of live web servers that should represent, ideally, the majority of public targets associated with that root domain that we can conduct testing on. This is all, you can just click, it will pull the information in automatically that you need and process it and give you the results that you want. All this is fully automated. And we even have an auto scan feature here. This doesn't exist for the company workflow because company workflow is a bit more complex and it's not as easy to automate. This is very easy to automate. So I built out a whole auto scan feature where you can go in and choose, I want these individual tools to run, and it's very granular. You can choose which tools you want to run. You can set limits on the subdomain, set limits on anything it's going to find, and then you just click a button and you walk away. And it's going to do this one by one. Like I said, when it finishes one phase, it'll pull the necessary data in, move on to the next phase. So I tried to make it as easy as possible. You can pause these, you can cancel the scans. These are all things we use version 1 that asked for. So all that has been built in, right now. In addition to that, at the end of the wildcard workflow, after you go through, you have the option to run a screenshot and a metadata report as well. Now the metadata especially is going to take a while. It runs FFUF, fuzzing for endpoints. It runs Katana, crawling, it checks for SSL certificates. It does all types of different things to collect and understand every single one of those target URLs that have been found. Now, the reason I built this out, and again, I've been doing YouTube for several years now, and I've talked to so many different bug bounty hunters, especially people that are first starting, and the one thing I hear over and over again is there's this very difficult point for beginners where they finish the subdomain enumeration, they have a list of URLs, but they don't know where to go after that. They just start testing them one by one and everything. So fundamentally, this ROI report will help solve that problem because it's going to go through and identify that and assign a score to every one of these URLs based on what's being found that will show the return on investment that a bug bounty hunter will get for that URL. So if it has a ton of different endpoints to be crawled, if the metadata scan is finding user-controlled input reflected in the DOM and it's not using React, there's all types of different things that will calculate through there. But this is something I want to continue building out over time, and I really want to bake my years of experience bug bounty hunting into this report so it can provide that guidance. And then when somebody's first starting and they hit that point and they finish the subdomain enumeration, they don't feel lost. They don't feel like they're wading out into a dark ocean. They have no idea where to go. They have some guidance. I want to give guidance on how to test it. Here's the technology stack. There's going to be some AI integrations going within this as well. But this is an option. You can continue after the wildcard workflow to go in and test the individual URLs using this ROI report. The other thing you can do, like I said, is you can pull that information back and we can continue the company workflow. So we'll talk through that. The last thing we need to find is we need to find the cloud assets. And then once we have that, we're going to go through and conduct nuclei scanning on the entire attack surface of the target there. So this is all brand new to version 2, aside from there were some basic components in the FireCloud script that was in there. But for the most part, I didn't have a lot of cloud enumeration here, and I'm really proud and happy of how this came out. So there's 4 different ways that we're going to enumerate cloud assets. So at this point, we have a list of root domains and subdomains and some DNS information that we've gotten from the wildcard workflow. We have their on-prem assets as well. So we have a lot of data that we can use. So now we're going to take this, and we have 4 different modules. We can use that data to try to expand our attack surface and enumerate those cloud assets. So the first thing we'll use is AMAS enum. And that's part of the wildcard workflow as well, but this is a much more targeted version of it with the goal of identifying things like CNAME records, PTR records, the things where we can tie the data that we already have to a known cloud FQDN, fully qualified domain name, so we can identify, hey, these are coming in through an ELB, these are using AWS Cognito, these are whatever it may be. We can get a better understanding of how this infrastructure is configured. We also go through DNSX, so that's a project discovery tool. It does the same thing as AMAS enum, but it gives a lot of enriched data for the domain names that are being discovered. It will tend to find things that AMAS enum doesn't. Even if it does not, it's still going to give you a lot of additional information that you can use at the end when you're looking at the attack surface and conducting your testing. So ultimately what we want to do is tie all this together so that we can identify the live web servers that can be targeted, what are the DNS records that are associated with it, is it hosted in the cloud, is it hosted on-prem, any information that we can get that will inform the type of testing that we want to conduct on that target. So after that, we're going to do cloud enum. Most of you probably heard about that. I'm going to talk more about that in the next slide because I did fork over my own version of it, and I've done several upgrades as part of that as well. But that's going to do brute forcing, right? So just like we did in the wildcard workflow, we're going to do brute forcing for the cloud assets, and then finally we're going to use Katana once again to crawl through everything that we have found. Just like we were looking for subdomains, now we're going to start looking for cloud domains, AWS Cognito identity pools, user pool IDs, anything that we can do to start conducting security testing on the cloud infrastructure that exists that's hosting our target there. Like I said, this is another thing that I just wanted to highlight. When I was going through, I've always used cloud enum as part of my process, part of my workflow. And as I was going through to get this set up, I realized there was a message in the README of Cloud Enum, very popular tool, where the developer essentially said it's not being maintained anymore and that they recommend using Nuclei instead. And I get that. Nuclei is good for that, but I like the tool, and I've always used it. So I decided I wanted to fork it over, and I'm going to be maintaining it moving forward. So if you want to use Cloud Enum completely separate of the framework itself, you can go ahead and download that and use it. It works exactly like the other one. I've also done a ton of updates, let's say, to it, right? It's a phenomenal tool. It was written a while ago, and the individual that wrote it, I think, was much more experienced with Azure pen testing and GCP pen testing, so there wasn't a lot of AWS stuff, and that's my specialty. So I went in there and added, I think there were 2 different AWS services originally. I now have over 14 services that are discovered. The S3 discovery logic is dramatically improved to the way things work today. We're going to identify redirects. We're going to test all the different domain name possibilities. So a lot of improvements there, and it's already been showing some results for me. Very happy about how that came out. Ultimately, once we go through, we are going to end up with the full attack surface of the target that we're testing on. So that's the ASN numbers, that's the network ranges that are included in those ASNs, any individual IP addresses, any individual domain names, the cloud assets, and then, like I said, all of those are going to combine together so that we're looking at the live web servers that we can conduct testing on. So we've got a protocol, we've got a domain or an IP, we've got a port, and we will be able to tell, okay, this has this DNS record and these IPs, and you can get a very quick picture of what that attack surface looks like. You can go through and explore all these, you can filter them, you can do searches and everything. So a lot of times what I do is I have this sitting next to Burp Suite, and I do my recon and everything there, transition over to Burp Suite, and I'll just go through and explore, find different targets there. We can also, like I said, we can conduct a nuclei scanning. So once we have the attack surface enumerated, any one of those targets that I showed back here, luckily nuclei is smart enough that you can give it any combination of these. So I can tell it, hey, here's an ASN, and here's a network range, and here's a list of IPs, and here's a URL, and nuclei will handle all of that for us. So essentially all you have to do is go into my tool. It's a full wrapper around nuclei. So you can configure it any way you can configure the CLI. You go into there, you choose, I want these targets as granular as you want to be. You choose these categories of templates that are going to run, these criticality, however you want to do it. You can upload your own custom templates as well. That's how you make money with Nuclei. If nobody's telling you that, go do your Recon methodology, write your own custom templates for things other people aren't working for or aren't looking for, and then you can go and run that. But yeah, full wrapper around that. You can search through the results. What I'm showing here is the modal of the results. So you can see it'll sort the findings. Every single scan that runs, you can go back and see that picture in time. So over time, you can go through and see how those nuclei scans change. You can filter them. Any results are... It's a full wrapper. It's a full wrapper. Anything you can do with Nuclei, it'll be built in here, and I tried to make it as easy as possible to use there. And then the last piece, and this goes back to where I was talking in the beginning, really fundamentally, this is meant to be an educational tool. Now, if you are very experienced at bug bounty hunting, you can definitely run it just as it is. You don't need to worry about these help me learn sections. You can also run it headless. So if you want to write your own complex scripts and just leverage the API and the Docker containers, 100%. If you've got the skill to do that, go for it. If, however, you're new to bug bounty hunting, and this is one of the first things that you've tested in, every single step of the methodology is going to include this help me learn accordion that you can drop down, and it will have descriptions on what are you doing, what part of the methodology are you doing, why are you doing it. We're always going to have the why behind what you're doing. What tools are you running? How do they work? What are you trying to find? Where are you moving on the next step? Every single one of these sections has this list here, and in each one of the major questions that you're answering, there's a learn more button on the side that's going to open up a modal with a custom dynamic lesson plan that I've written out and includes tips for bug bounty hunters. Every single one has 5 or 6 links for external resources. So the goal is you download this as you're going through and running the scans on real-world bug bounty targets. You are also learning and everything. And this is going to tie back into my education. My YouTube channel, I'm going to start making videos and put my YouTube videos to walk you through using the framework at each step so you understand even more there. So, moving forward from this, just set expectations. So the first 2 things that I've got to do with this, because it's been a rush to get everything ready for this beta launch. Number 1, if you've ever worked with me, you've heard me say this before, I've got to untangle the spaghetti. I have written a lot of code. Some of it's good, some of it's terrible. Please don't look at it right now. Give me a couple minutes and I'll get it. But yeah, I've got to go back. I've got to do a lot of refactoring and everything and get it to the point where it's going to scale the way that I need to be. And the other big thing is performance, right? You're going to see as you start to get a large number of subdomains and results and nuclei scanning and everything, there's a lot of data that doesn't need to be stored in state and props in the browser that's being stored in there. I got to get that cleaned up. I got a lot of work to do there. But if I can focus on performance optimization in the near future, I think it's going to work for just about everybody. Outside of that, like I said, the educational content. I've got a lot of written stuff in there, but I'm going to continue working on the videos and all that will be included. I want to listen and hear where people are having friction as they're going through so that I can add in additional information. But I want to make sure that this tool has the educational information that will really help the people that are starting there. Bug fixes, feature requests, right? As people are starting to use it, and I'm starting to get the feedback coming in now, if you run into any issues, definitely let me know. I'm going to be keeping an eye on that. And then finally, like I said, the URL workflow, I'm going to start building that out probably in about 6 to 8 months once we get everything a little more stable, as well as my AI feature. So I've already started to build these out, and they're working a little bit. You can run a profile in the Docker Compose if you want to test them out. But there's going to be a chatbot with a RAG system on the back end so that you can open up and ask it any questions about your data. So if you found a bunch of information about targets, you can go up and ask, which one of these target URLs would be good for client-side injection testing, would be good for cross-site scripting, whatever it is, and it will go through and identify that. I'm also going to have sections at the root domain and at the ROI report so we can feed all that data into an AI system and it can give you human language information about what you're seeing. For the root domains, it will try and determine whether or not that root domain is actually owned by the company. And one of the things I do with that is I look for like the company name match within the DOM, things like that, but we're going to get AI in to get a little better. And on the ROI report, that's where it's going to tell you, hey, this is in human language, this is how you should test it. These are the types of things that I'm seeing now. All right, wrapping up here. Again, thank you very much. So if you want to do anything to support the project, the number one thing that you can do is just share it out. If you know anybody that's interested in getting started with bug bounty hunting, please just put that on their radar. I'm happy to help. I've got my YouTube and everything else there. Again, if you are using it and you run into any issues, you have any feature requests or anything that you want to use, you can submit that through the GitHub discussions, the issues, anything like that. But yeah, I just want everybody to use it, hopefully find your own version of success with bug bounties. And the last thing I'm going to leave up here, this is a QR code for a video on my YouTube that just released this morning. This is a 2-hour demo walking through with my tool everything that I just talked about. So I tried to do the high level here. If you want to go through and actually see me install the tool and use every single component, all you have to do is use that QR code. The video is up right now. That's all I got. Thank you all very much. Good. Thank you. Yeah. Be happy to answer any questions. If anybody has any questions? Yeah, what you got? Yeah, so that's a fair point. This is not a phishing thing, just to be clear. Go to YouTube and just type in rs0n_live. rs0n_live. That's my YouTube, Arson Live. Yeah, rs0n should find it as well. Yeah, what you got?
I was wondering how to run those properly. Because, for example, if I run my stock computer, CPR,
Yeah.
and if I run, maybe if I run it in EC2, I'm wondering if it will trigger abuse report.
100%. 100%. Yeah. So here's what I can tell you. It's not built to be cloud native right now. I'm actually planning on doing a split between the two. So it's not, you can definitely run it on an EC2, but it's, right, I want to get it built cloud native where you can just go to the IP and everything there. But it's really built right now to run as like a desktop application. And I think I'm going to do an Electron kind of version of it. But yeah, in my mind, the correct way to run it would be as a desktop application running there.
Maybe my home lab.
Yeah, home lab, absolutely. Yeah. What you got, man?
Is there an authenticated recon for it?
Not yet. So that'll be probably part of the URL. I could do some authentication for the crawling pieces, which is definitely something I can look at. But yeah, not yet. But yeah, definitely. What's up, man? Oh, thank you. Yeah, sure. So thank you. And he asked, in a lot of my videos, I show a manual testing. He asked how the framework fits in with that. The framework, the way that I use it, is it's essentially all of my Recon is over on this screen, and then I have Burp Suite over here, and then I have my notes on my third screen over there. This shows me the full attack surface, and I'm constantly pivoting back and forth between that and Burp Suite to go in and do that manual testing. So it's always a process of you step into that manual testing, and then when you hit a wall, you step back out and go to Recon. But it's a constant flow back and forth between that and Burp Suite, doing that manual testing. Cool. Thank you. What's up, man?
So does your tool have what kind of whack detection, if any, does your tool do? Because I figured that's one of the main roadblocks I've had attempting bug bounty has always been how do I bypass things like Cloudflare and stuff like that.
Yeah.
Is the issue that I've been dealing with.
Yeah. No, that's a great question. So the ROI report is where we would identify. That's one of the checks that it does. And that would be worked into the score, and it would tell you there. I will tell you, it doesn't have a huge impact on the score yet, and here's why. A web application firewall definitely makes it harder to do some things like you're talking about. It also, historically, tends to make web applications less secure, because people rely on that as opposed to other things. So. Exactly, yeah. So what it would do, and eventually this is where I'll continue to build it out, it will tell you, hey, there's a web application firewall, so you're probably not going to find the basic like client-side injections, server-side injections. Maybe don't test on injections on these, but look for logic, things like that, because they probably have a false sense of security.
Got it.
Cool. Yeah. All right. What's up, man?
So in version 1 you had...
I did, yeah.
So you had the scope there.
Yep.
From Packer 1 or different companies like that, you were able to import a file to get the scope set up.
Yep.
Do you have that currently, or in the future you're going to have that under certain programs?
I definitely can. I don't have it right now. I think you built that, didn't you? Is that why you're asking about that? I thought, yeah. I can do it. I can do it. I was going to say, if you want, I got to consult with you.
As a beginner, that's one of the things I didn't know was like following the scope, right? I mean, a list of subdomains. I'm like, I'm going to test them all.
Yeah.
I didn't realize that can actually wait my mom.
Yeah. Oh, yeah. It's great. Yeah. Yeah, no, it's 100%. I'll get it built in there. I loved it in the last one. I do want to, this is something I've been thinking about a lot, and I think I'm going to build in soon, be able to upload the scope or identify the scope, and then have it identify anything that's out of scope. So I don't know how, as it goes through and collects. Now, that's quite difficult for some of them, but I think at least for the basic ones, we can get there. Yeah, man. Cool. What you got? Yeah, so the backend, there's about 20 Docker containers altogether in the framework. The two main ones are the client and the backend server. And the backend server has an API with about 250 endpoints, and it has the documentation and everything built in there. Oh, No. So no, there's no specific like differentiation between APIs or anything else. It would treat any API URL as any other URL. What it does do is if it identifies a target URL that the root endpoint is a 404, just as an example, it will identify that as an API, and you can go different testing and everything for it, but that's probably it. Cool. All right. Happy to answer any other questions. Yeah, please go ahead, and then I'll go to you. So it depends on the strategy that I'm using. So I call them work streams, and if anybody's worked in a big company for it, it'll make. But so it depends on what type of work stream I'm doing. I typically do 3 or 4 different types. So one of the things we're going to start doing soon is a deep dive on the Grammarly one, and we're going to focus on cloud infrastructure and AI vulnerabilities that are there. I do things where when new CVEs are released, when NPM packages and everything, scan across all the data that I have. So it depends on the work stream there, but I choose the strategy of hunting first, and then I choose what targets I'm going to hunt. And that's something I see a lot of people make the mistake of. They choose the target and then try to go in and test or do everything, right? Bug bounty hunting is not a pen test. We want to figure out what we want to test for. I want to find OAuth. Okay, I need to go find every target that has OAuth, and that's going to be my work stream, and I'm going to scan across and do that. So there's usually about 4 or 5 kind of going on at the same time. Cool. Do you have something?
How long it usually take to get the result? Because I guess the IP range for public is so large.
There's no good answer. It's different for everybody. It's bug bounty hunting, I always say, is an Easter egg hunt. It really is that. There's a big portion of luck involved. The more you have skills and can build up those types of things, you can put luck on your side, but there's always a thing of luck to it. And that's why if you see what I do bug bounty hunting, but I also do consulting on the side and everything, so that I have a full-time job right now, but when I did this full-time, I had multiple different streams of income, and bug bounty hunting was a part of it, because there are just times when it's uncontrollable and there may not be that availability out there.
Okay. Is that possible to have a database background? For example, if my teammates all use it together, I just want to avoid rerun the duplicate scans.
Yeah, are you talking about for the framework?
Yes.
I would just do individual instances. Yeah, as of right now, it just connects back to one database. You wouldn't take that long to get it set up to do that. I can build that out as a feature if you want to just be able to point it to different databases. But yeah, I would just do different instances of it, run it like a desktop app. Good. Cool. I haven't looked at the time here. I hope we're okay. We all right? Okay. Okay, perfect. Yeah. You got any more questions? And please go ahead.
So how would you approach a CPI? More like a pen test.
Yeah.
How would you approach that?
We have a bug bounty CTF app.
There you go. So it would depend on what type of CTF. Ultimately, every CTF is different, right? So if the CTF doesn't require you to conduct recon across an entire company's attack surface, the framework probably wouldn't fit into that, because that's really the piece of the overall methodology where it fits in. Cool. All right. Yeah. Thank you all so much. Let me know if you have any other questions. I'll be out there. But yeah, otherwise, we're DEFCON. Thank you. Appreciate it.